Welcome to EduMoon. Hello guys, this is Sindhu and today our topic is analysis of coal. Coal is the most important solid fuel and is highly carbonious. It is used for various industrial as well as domestic purposes. But before using, we have to analyze and know what is present in the coal. Coal contains various contents, that is carbon, ash, moisture, C, H, N, S. All these are known by analysis of coal. Analysis of coal. It is of two types, proximate analysis and ultimate analysis. Proximate analysis is easy and quicker. It gives a fair idea of quality of coal. Whereas ultimate analysis is essential for calculating the heat balance in any process for which coal is employed as a fuel. Proximate analysis deal with moisture percentage, volatile matter percentage, ash percentage, fixed carbon percentage. Whereas ultimate analysis deal with carbon and hydrogen percentage, nitrogen percentage, sulfur percentage, ash percentage and oxygen percentage. What is the purpose of analysis of coal? It is to determine the quality of coal. Why are we doing this? To determine the quality of coal and also to decide the price of coal. We can decide the price of coal only by knowing the quality of coal, right? So, to decide the price of coal also, we have to do the analysis of coal. And to specify the use of coal for a particular purpose. We have lot of purposes. We can use coal in different types of purposes for domestic and industrial purposes. But we have to know which coal should be used for this purpose. So, to specify the purpose, we have to conduct the analysis of coal. And the next one is to calculate the theoretical calorific value of coal. For this one also we have to conduct the analysis of coal. And also to calculate the air requirement for complete combustion of coal. To calculate this is very important because if the air requirement is less, then if the air is given less than required, then the carbon will forms carbon monoxide then forming carbon dioxide, which is very harmful to our health. So we have to calculate the air requirement for complete combustion of coal, which is very important. So the purpose of analysis of coal are these, and analysis of coal is very important. Coming to proximate analysis, it deals with moisture content, volatile content, ash content and fixed carbon content. Proximate analysis, which includes the determination of these, will give us quick valuable information regarding the commercial classification and determination of suitability for particular industrial use. Percent. In any substance, to know the moisture content, we have to heat it. After heating, it will lose the moisture in the form of evaporation. And when we weigh that after evaporation, when we will get some weight, and the loss in weight will be considered as the amount of moisture. In the same way, here also we are taking the coal, and when coal is burnt, the moisture in it will evaporate, and this moisture will take away some of the liberated heat in the form of latent heat of vaporization. Therefore, the presence of moisture will lower the effective calorific value of coal, and it will also decrease the fire in the furnace. So, lesser the moisture content, better will be the quality of coal as a fuel. And now the determination of moisture is about 1 gram of finely powdered coal sample is taken. Here we have to mention crucible because we are weighing it 1 gram. See, and 1 gram of dried coal sample is taken, and then it is placed in hot air oven or electric hot air oven at 105 to 110 degrees Celsius. It is also important to mention these 105 degrees Celsius to 110 degrees Celsius. It is important to mention. And After keeping this, and the crucial is kept for 1 hour and taken out and cooled in desiccation and weighed. Loss in weight is reported on percentage basis. The percentage of moisture is loss in weight by weight of coal into 100. This is the percentage of moisture. It is nothing but 1 gram of coal is taken and it is kept in a 105 degrees Celsius to 110 degrees Celsius. We have to heat it and then we have to leave it for 1 hour. Then we have to calculate the loss in weight, which is nothing but the percentage of moisture. Volatile matter. If the content of volatile matter is high, it means large part of fuel will escape unburned. Hence, the coal with higher volatile content is undesirable. Lesser the volatile matter, better will be the rank of coal. And the determination of volatile matter, the procedure for the determination of moisture is repeated, and then the dried sample of the coal left in the crucible is covered with a lid and again it is heated at 925 degrees Celsius plus or minus 20 degrees Celsius, and it is taken after 7 minutes and it is cooled and then weighed again. The loss in weight will be given as volatile matter, and the percentage of volatile matter is loss in weight due to removal of volatile matter into 100 by weight of coal sample taken. Ash. Ash is a useless non-combustible matter and it reduces the calorific value of coal. It hinders the flow of air and heat, thereby lowering the temperature. It also causes the early wear of furnace walls, and ash disposal becomes a very big problem. Hence, lower the ash content, the better quality of coal will be taken. So, determination of ash content, then the coal, the residual rock in the crucible is again heated without a lid in muffled furnace at 700 degrees Celsius for 30 minutes. The crucible after taking out is cooled in air and then desiccated and weighed. Then percentage of ash equals to weight of ash left by weight of coal taken into 100. And the next one is fixed carbon. Percentage of fixed carbon equals to 100 minus percentage of moisture plus volatile matter plus ash. Hence, in approximate analysis, we find the percentage of moisture, volatile matter, fixed carbon and ash in the coal. This approximate analysis gives the approximate composition of main constituents of coal. These results will help in deciding the use of coal for the particular industry. Ultimate analysis. By this method, weight percentage of carbon, hydrogen, nitrogen, sulphur of pure coal free from moisture and inorganic constituents is found out. Hence, it is an analysis of elementary constituents of coal. Carbon and hydrogen. The significance is greater the percentage of carbon, greater will be the quality and calorific value of coal. And greater the percentage of hydrogen, better will be the coal quality and calorific value. But the hydrogen will be mostly associated with the volatile matter. When coal, which contains more of the hydrogen, is heated, it will combine with nitrogen present in the coal, forming NH3. This NH3 is recovered as NH4 2SO2, a useful fertilizer. So, a value of hydrogen is also very important, as it is the value of carbon is important. Now, coming to the determination of carbon and hydrogen, a known weight. For example, let's take about 1.2 grams of accurately weighed coal sample and it is burnt in oxygen, that is coal plus O2. Then C and H in the present in the coal are converted into CO2 and H2O. By the formula, C plus O2 gives rise to CO2 and H plus half O2 gives rise to H2O. And the products of combustion are observed respectively in KOH and CaCl2. That is nothing but 2 KOH plus CO2 gives rise to K2CO plus H2O. And similarly, CaCl2 plus H2O gives rise to CaCl7H2O. Then the percentage of carbon is given as increase in weight of KOH tube by weight of a coal sample taken into 12 12 into 100 by 44, because here we are taking the weights, and the percentage of hydrogen is equals to increase of weight of CaCl2 by weight of coal sample taken into 2 into 100 by 18. Okay. Coming to nitrogen, it is undesirable because it has no calorific value, but sometimes N2 is reacted with H2 and NH3 is formed, and it is recovered in the form of NH4 by SO4. It is a valuable fertilizer. And now coming to determination of nitrogen in coal, about 1 gram of weighed powdered coal is taken and it is heated with concentrated H2SO4 in K2SO4. Then it later created with KOH, and the liberated ammonia is distilled over observed in known volume of standard acid solution, and unused acid is determined by back filtration with NaOH solution, and the percentage of N equals to volume of acid used into normality into 14 by weight of coal taken. And we can see this in the form. See, let the volume of XnH2SO4 equals to A ml and volume of unused NH2SO4 is B ml. Then we can, and acid neutralized by ammonia equals to A minus B ml. Here H2SO4 is taken as A, and H2SO4 unused is taken as B ml, and the acid neutralized by ammonia equals to A minus B ml. And now 1000 ml of 1N acid equals to 14 grams of N2. Here 14 grams of N2. Then A minus B ml of Xn acid equals to 14 into A minus B Xn by 1000 into 1 grams of N2. Then the percentage of N2 in coal is given by nothing but A minus B ml of Xn acid, that is 14 minus A minus B Xn by 1000 into 100 by W, that is 14 into volume of acid used into normality by 1000 into W into 100. That is nothing but 1.4 into volume of acid is used into normality by W. Coming to sulfur, sulfur causes corrosion and also harmful to atmosphere, because sulfur produces acid which has harmful effect on corroding equipments, and also it causes atmospheric pollution. The determination of sulfur, it is determined from the washings obtained from unknown known mass of coal. During the determination, sulfur is converted to sulfate. Washings are treated with BaCl2 solution when BaSO4 is precipitated, and the precipitate is filtered, washed and heated to a constant weight. The percentage of sulfur is weight of BaSO4 obtained into 32 into 100 by weight of coal sample into 233. Because here, see, here S plus 2O2 gives rise to SO2, right? And then it is treated with BaCl2. Then it is formed as BaSO4. And now this BaSO4 is precipitated and weighed. So the percentage of, when we take it as X grams of BaSO4, then we have to take the percentage of sulfur in coal as 32 into X. X is nothing but grams of BaSO4, and 233 into W. W is nothing but the weight of coal taken into 100. And this is the main thing: oxygen content and ash content. When the oxygen content in the coal is high, the inherent moisture content will be high. It will have low calorific value. Further, if the oxygen content is there, it will be in the combination with hydrogen in coal, and hence it will decrease the combustion. So the presence of oxygen will lower the quality of coal, and the determination of oxygen in coal is given as percentage of oxygen in coal is nothing but the 100 minus percentage of C plus H plus N plus ash. And now the ash. Ash is nothing but it will be determined in the same way as we did in proximate analysis. Okay, now it's done. We deal with the proximate analysis and also ultimate analysis. Thanks for watching. This is Sindhu and please subscribe to EduMoon for more videos.